Hi everyone, welcome to Workshop 7. Today we're going to be talking about an intro to reverse engineering. So today we're first going to talk about what exactly is reverse engineering. Then we're going to discuss, what needs to be reverse engineered in CTF challenges and skills and tools that are useful for reverse engineering. And then we're going to do a short example from Pico CTF. So let's get started. What exactly is reverse engineering? Well, a simple definition can be, it's taking something apart and putting it back together again to understand how it works. And an example I can give is of a bicycle. So if someone wanted to understand how a bicycle works and how each component contributes to the overall bicycle, they could take the bicycle apart. So for example, if they took the brakes apart and ran the bike, they'd see that the brakes contribute to helping the bike stop. And so they could test what each component of the bicycle does to really understand how all the components come together and what role each component plays. And this would really help them understand how a bicycle works. So real life use cases of this are analyzing malware and malicious programs to understand how they work to prevent against them. If you can see what is contributing to a malicious activity in a program, you can try to break it apart and see what exactly it's doing, and you can better protect your systems. You can break down code to better understand the potential vulnerability of a software. And you can also understand how certain parts of a program work by taking it apart, by analyzing it. So what exactly needs to be reverse engineered in CTF challenges? Well, you might be given some code, you might be given binary files, assembly instructions, malware, applications, programs written in Python, C, Java, any language really. So that's why it's really important to have some prerequisite skills for reverse engineering. And we're going to now talk about what skills and tools are useful for reverse engineering. So it's important to have a basic programming knowledge to understand how programs work. So it's important, to be able to, at the minimum level, be able to read some code like Java, Python, C. It's important to understand how assembly instructions and registers work. It's important to understand how memory allocation works. And some tools that can help you and to really help you analyze these problems in these softwares. There's debuggers. Debuggers allow you to step through a program one line at a time. So that's really helpful. You could see what's happening at each line of the program. Then there are disassemblers. And disassemblers break down a compiled program into machine code. And then you have decompilers. Decompilers are tools used to convert an executable program or low-level machine language into a human-readable format or high-level language like C. So now that we've discussed about what reverse engineering is, let's take a look at one of the problems from Pico CTF. Now we are going to look at the problem transformation from Pico CTF. So we are given an encoded file or a file that says ENC, and then we're given this line of code right here, looks like Python, and then our hint is you may find some decoders online. So let's see what the problem is. Before we go and open up this, let's open up this encoded file and see what we have. So we're presented with this, and this looks like writing in another language. We don't really know what format that is. So to figure out what format that is, we can use the file command in Pico CTF and figure out what type of file this is exactly. If we open up our web shell and log in so that we can figure out what type of file this is, okay, so now what we have to do is we have to copy this. Let's use wget to get this. And now it has been saved. And let's use ls to see what files we have. It's been saved as enc. So let's use file command and then enc to figure out what type of file this is. Well, this is a Unicode text UTF-8 file. Okay, so that gives us a little bit of information with what we're working with. So I guess inside of this file, we have some Unicode characters. So now let's take a look at what the Python code is doing. So basically this code shows us how the flag was encoded using Python. And let's take a look at it right here. So 2 characters are converted at a time. It's doing 2 characters at a time, and it's going through an iteration process. And then the 2 characters are converted into a binary 16-bit, then converted into an ASCII character. If you want a really good explanation on what exactly everything that's happening in a code, and then actually see how the binary is shifted and broken down, then I have attached a blog post for reference, and it does a really good job at breaking down everything that's going on in the code. So let's actually try to solve what's happening with the code. So now I'm going to show you how to solve this in an easy way using a website that I've mentioned in one of the workshops before called CyberChef. You know, there's a lot of encoding options, decoding, encoding options on this website, and, you know, converting from different data formats like hex to binary, etc. So this is a very useful website, and I've linked it in the description below for anyone that's interested. So let's take a look at the different data formats they have. So this is to char code, so it converts text to its Unicode character code equivalent, and from char code converts Unicode character back into text. So let's do to char code so that we can convert the Unicode character to its code equivalent, so that we can convert this string into its Unicode character code equivalent, and we can get our hexadecimal value. So once we do that, we're given this hexadecimal value, and we can convert hex to ASCII to see if we can figure out the flag. So for hex to ASCII, I'm going to be using the website that I've already discussed before as well, Rapid Tables. So over here, I'm going to just paste the hex and convert. And here we have our flag. So this is really cool. The thing is that, you know, reverse engineering, so if you understand what the code is doing, you can work back from there, or you can, you know, try different tools and tips and tricks that we've learned to arrive at a faster solution using CyberChef. And that was it for today's workshop. Thank you for your time. Make sure to check out the blog post about transformation problem. It really details and talks about the code in a really, really detailed and good way that makes it really easy to understand. Also check out CyberChef for when solving these type of problems. See you next week.